Hi, good afternoon, good morning, good evening, depending on what part of the world you're in. I'm very excited to be here. My name is Stephen Millman. I'm the Global Head of Research and Data Science at Dynata. And on behalf of Dynata, really delighted to welcome you to this event. There's nowhere I would rather be spending my birthday. So thank you all for attending. We have a great program. Along with me today is Nancy Brigham, Vice President, Head of Research Science at Dynata, who leads our data quality work. She is going to take you through the bulk of the presentation. She's fantastic. And I'm also excited to have two senior experts from the industry joining us today, who I'll introduce later, but Chris D'Agostino of Databricks and Paul Donato of the Advertising Research Foundation. A couple of quick housekeeping notes. The presentation will last about 10 minutes, and then we will start the panel with Chris and Paul. That'll last for about 15 minutes, and then we'll take any questions that you have. I encourage you to please put your questions in the Q&A as we are going, so we have a list of questions when we get to that point. We'll be able to see them and tally them as we go. The webinar is being recorded. Will be available to watch on demand right after the session. You'll receive an email from our On24 platform with a link to access the recording. You're welcome to share it with your contacts or just listen to it again. Second, we'd like the session to be as interactive as possible. Again, please do use the Ask Question box, which should be just below this window on the webcam. We'll try to answer as many questions as we can at the end. If we don't have time to answer all of them, we'll try to reach out to you individually and catch up to you by email. All right. So quickly, I'm going to just do a little level setting about what is artificial intelligence versus machine learning versus generative AI. Artificial intelligence is a very broad term. It simply refers to the ability of machines to mimic human intelligence. Lots of examples of these that you're all used to seeing over the last couple of decades: natural language processing, recognition, robotics, self-driving cars. Machine learning is a subset of AI, and this allows machines to learn from data without being explicitly programmed. So this is where you take large data sets and then use them to help predict things that it didn't see in that data set. And then finally, generative AI, which we've all heard a lot about in the last year. Things like ChatGPT. These are artificial intelligence models trained on vast amounts of text data. They generate human-like text. They predict the likelihood of a word being used given the context of the prompt and previous words used. They're great at translation, answering, and creating human-like chatbot responses. Generative AI is also good at writing stuff like this. Not exactly how I would have written it. This was written by Bard, which is Google's large language model, but did a pretty good job. Why are we talking about large language models? Because they have exploded. ChatGPT made the decision, OpenAI made the decision to give everybody the access to their systems. And suddenly these AI tools, which previously required PhDs and lots of firepower, became available to the masses. On the back of that, everybody else who had been working on this for the last few years, some going back 10 years, suddenly said, we've got to make ours available too and keep up. And as you can see here, a massive explosion in the availability of large language models in the last year. Bard, in fact, just a week or so back, has moved to their new version, which is Gemini, which is natively multimedia. Couple of quick things. What did generative AI do well and poorly? Generative AI is a language model, and it's really important that you remember it's a language model. So it's very, very good at human language, at responding to things that are in the data set. Anything that it can draw upon from the foundational model can be pulled out as answers. And it's excellent for things like copilots, for translations, summarization, open text coding. Turns out that it's a language model. Again, it's not great at math. and you shouldn't expect it to be great at math. It doesn't manage structured data sets particularly well. It doesn't do math problems well unless they're clearly lined up as steps. And interestingly, it does a reasonably poor job at lit reviews. Again, it's not a search engine, although there are now search engines which have Gen AI embedded in them. And so when you ask it to do a lit review, it often will make things up, which you want to avoid. So with that, I'm going to turn this over to my colleague, Nancy Brigham, and she's going to take you through the bulk of this presentation. Then you'll be back to me and the panel for the conversation. And for those of you who've said it in the Q&A, thank you for the happy birthday wishes. I appreciate it.
Thanks, Stephen. Hi, everybody. I'm happy to talk with you today. I'm going to spend a few minutes focusing on respondent quality, which is a foundational element of your overall data quality. And I know every person on this webinar has kind of lived the challenges that the industry has faced in the past 10 years, especially with fraud, and then, of course, the decrease in survey engagement. I just want to set the stage that any successful quality system today needs to be systematic and holistic. So it's not just one quality product or even several products used together. It's much bigger than that. It's a complete research ecosystem, and we have to think about it that way. Respondent quality has to be conceptualized and implemented in a systematic way, addressing respondent motivations and using all types of data we can access to continuously learn and update our predictions, and then, of course, the actions we take from those predictions. So it's only with this approach that we can successfully counter the more sophisticated fraud that we see today, and to make more nuanced decisions about levels of survey engagement, ensuring that we don't skew a study's data by throwing out good respondents along with the bad. And I am just gonna get, so, where does AI come into play? So today's sample landscape is fast evolving, and using advanced technology like AI is critical in the fight for ensuring your insights are based on the right respondents, real people who are thoughtfully and faithfully responding to our surveys. As I mentioned, we also need to ensure we're not being overzealous and throwing out good respondents when we throw out the bad ones, because that can skew your insights in different ways. For us, AI, or machine learning, which is what we're using for quality, has been a game changer for us. Fraud in our panels, Dynadas panels, is now extremely low. It's the lowest in the industry based on publicly available figures. And we're able to get even more nuanced about who we remove and who we keep on our panels and in our surveys, which protects respondent engagement as well. And this is due to the machine learning models that we've incorporated into our respondent quality systems over the past 5 years, and especially in the past 2 years. We've taken a focused and sustained, and some might even say aggressive, approach to shoring up our data quality system. And this has really paid dividends for our data quality. So how has it helped us and can help you elevate data quality? So I'm going to just briefly cover 5 tips to get there. On the surface, fraud and disengagement can look the same. For example, poor responses in the survey. But what's key to addressing and solving for fraud and disengagement is that the underlying motivations are different. So we need to understand the motivations for a respondent's behavior, and then we can directly address or remove those motivations. For example, the motivation for fraud is money. Fraud is simply a job for fraudsters who have revenue goals just like anybody does. We need to treat it that way and attack their motivation. If the money isn't there or it's too hard to get, then they're not going to attack us. Conversely, they'll spend effort and money to get around our defenses if they can see a path to ultimately making more money. So there are various ways we reduce their ability to make money, such as ID validation before they can redeem their incentives, or reducing their ability to quickly take many surveys, or requiring 2-factor authentication to join the panel. So those are just some of the ways. On the other hand, though, the motivations for disengagement are pretty varied. A respondent could simply be having a bad day, or they were momentarily distracted by their child, or they turned out out of a lot of studies, and so they suffice on a screener to just to be able to take a survey, or maybe they got turned off the survey experience because the survey was just a poor experience. So here, in this case, we have to take different actions depending on the scope and intent of the disengagement. So most of the time, these folks are good respondents, so we don't want to drop them entirely. We want to take the appropriate actions for a particular survey and then educate the respondents on how to be better respondents. For example, at Dyneta, we're currently implementing an education path where we can send folks who are quarantined for disengagement so that then they can complete learning tasks. Secondly, it's critical in today's fraud landscape to take an holistic, multi-layered metadata approach. We need to assess respondents across all touch points with every interaction we have with them, from when they're first recruited to being sampled and sent to surveys, when they're taking a survey, when they're redeeming their loyalty points for rewards across their entire lifetime with us. You might also hear this called a full history approach. Each interaction is a chance to evaluate and update our predictions as to quality. This can be thousands of data points. The more data we have on a respondent, the better our predictions are, the faster we can act, and the higher the chance they won't affect a study's data. Because fraudsters are pretty sophisticated these days, we can't catch them with only one approach. They don't speed anymore. They know we look for it. So we need to layer different types of quality checks throughout the system, catching them in multiple ways. And it's not enough to only use one or two types of data anymore, such as just behavioral data. It's important to use the metadata we get as a respondent moves through the research process in our systems. For example, passive data, such as how they're using their mouse, or calculated deviations between several device parameters that suggest fraud. AI models need data. So we need to use many different types of data and lots of it. The more data in general, the better for AI prediction. So I mentioned passive data. This is how a respondent indirectly behaves during the survey taking process, such as accelerating through the survey, using blunt force approaches, copying, pasting their open ends, etc. Passive data is becoming especially important in today's world with the move away from dropping cookies or allowing browsers to track, and of course with what Stephen was talking about, the emergence of Gen AI for the masses. We also use types of data like calculated data, historical data, real world data, manual review. Those are just some of the things. Our latest data type actually is client feedback at each project level that is uploaded, goes directly into our machine learning models. One note here, it's important to curate and be very choiceful with this data. So data gathering and analysis is actually the most time-consuming part of creating machine learning models. It doesn't help to use data that doesn't affect the outcome, or that you have so much data that you get diminishing returns in terms of efficacy. We should let AI measure levels of engagement within the survey and help you make calls in this area as to who to remove from the data. People spend a lot of time doing manual review of their data. And they often wonder about when do we draw the line for engagement. We're all disengaged at some point during our daily life. We can't do everything 100% perfectly every day. It's the same with our respondents. We can't expect that they're going to be 100% perfect on every study. They may be disengaged on a question or two, or they don't like answering open-ended questions, or they didn't pay a lot of attention to one of the sections because their child was crying, or they got really annoyed because the survey was too long, and so they kind of hurried toward the end. But on average, we may assess that they were fairly engaged with the survey. When we start removing people from the survey, especially for being disengaged at some point, we run the risk of actually biasing our data and skewing representativity. So we cause one issue while we're trying to solve another. AI can help us make those decisions in a more nuanced fashion, in a more consistent manner across surveys, and in an automated way, all of which helps guard bias in your studies and which saves you time. Lastly, machine learning is not set and forget or inherently smart. The models themselves are only as smart as the analysts and developers who create them. These analysts and developers need to understand the quality issues, what we're trying to solve for, the competition, which in this case is fraudsters, bad surveys, respondents' busy lives, things like that. They need to be able to analyze data and add new patterns to the models. They need to anticipate and quickly adapt and pivot as needed, such as when it became apparent that that Gen AI was going to be launched for the masses. We had to pivot, for example. They need to be able to understand the entire research ecosystem and implement the right feedback loops and data sources, and much more. So as you can imagine, success requires a significant commitment by a company, both in costs, efforts, and full-time resources. But the payoff in quality is huge. Here's an example of a key machine learning model where we applied all of these tips, plus more, for success. So Quality Store is one of our major machine learning models. It runs while a respondent is taking a survey and also at recruitment. It evaluates, identifies, and takes action on both fraud and disengagement. So it not only removes the bad folks and replaces them with good respondents, it also helps dimensionalize levels of engagement with your survey so you can remove only those who are truly necessary to remove. Like I mentioned, there's a real risk to overcleaning your data. You can skew the representativity in ways that you don't understand and that the statistics can't handle. And you can add your own bias into the cleaning and thus adding your own bias into your data. You started out with a rep sample, but what you end up with is something else entirely. So Quality Score uses AI to help make those decisions for you. It assesses over 175 data points, both passive and behavioral, to predict whether a respondent is fraudulent or is being too inattentive. It looks at common behavioral elements such as speeding, straight lining, open ends, but it also looks at passive elements that you or I could not readily see, such as accelerating through the survey, mouse movements, or automated blunt force approaches. This lets us identify bots and other automated fraud if somehow they make it into the survey. And not only does this help with not over cleaning, it saves you time. It's been estimated by one of our clients that it saved them 85% of the time they previously spent in manual cleaning of their data. This Quality Score is the survey quality solution we use for all the surveys we host at Dynata. So if we're hosting your survey, you're already getting Quality Score. From a sample-only standpoint, we're also piloting it as a potential solution for our sample-only customers. So these are folks who buy our sample, but they host their own surveys. So stay tuned for more to come on this. Now I'm going to turn it back over to Stephen to hear from our panelists.
Thank you so much. So let me bring on Chris and Paul. Go ahead and turn on your video. Really happy to see you guys here today. Chris D'Agostino is Global Field Chief Technology Officer for Databricks. He's been with Databricks for a little over 4 years and has 30 years experience in dealing with large-scale data environments. He was previously at Capital One and was a CEO of a data analytics company that was focused on counterterrorism after 9/11. Paul Donato, Chief Research Officer at the Advertising Research Foundation, the ARF, and a good friend and mentor. He spent, I think, 17 years as the Chief Research Officer of Nielsen. He knows all, he tells all, he's a heck of a guy. Thank you guys so much for joining us.
Thanks, Steve.
Also on the panel, thank you. Also on the panel, Nancy, who you have become previously acquainted. So I'm going to start asking the panel some questions. Once again, I'd like to remind everyone, please put your questions that you'd like this panel to respond to in the Q&A, and we will continue to go through those when we get to the Q&A section. All right. Paul, the first one I'm going to direct at you, but as with all the questions, when you're done, feel free if anyone wants to add something to do so. So we talked a fair bit about data quality as it pertains to panelists. How else are you seeing AI being used to fight data fraud in the advertising ecosystem?
A couple of places. On top of what Nancy had mentioned, One, of course, is using facial recognition. So there's a number of companies that started out really as creative testing using eye tracking, and they've converted their services over to something which will look for duplications of face responding to a survey. They publish numbers that it has minimal impact on the overall response rate among surveys. Maybe 13% refuse to use the camera, and all possibility that 13% is heavily loaded with fraudsters. So that's one use of technology. We mentioned mouse movements and things like that. That has been around for a while. We are working on a system which does just the opposite. I mean, really good bad actors are dealing with, say, correlations between questions. There are some questions which are naturally correlated with others. We are actually working on a system right now that will do consistency checks without manually going in and doing anything, but asking AI to look for questions that ought to be correlated, and based on those scores, identify people that are potentially fraudsters. Outside of survey, I think there's a fairly significant fear about deep fakes being used in advertising creative. Although everybody from the Pentagon to Intel now has software. Intel advertises a process which they believe is 97% accurate in identifying even a really good deep fake.
That's great. Thank you. Anyone else want to add to that other than my dogs? Okay. This one's for you, Chris. How are technology companies like Databricks working to provide new tools to prevent data fraud?
Yeah, one, appreciate being here, and forgive me for being a little sick. I maybe sound a little bit like the dog there in the background. So Databricks has been really focused on making sure that you have end-to-end awareness of where the data that you're working with has come from, so the source system, and understanding the history of data that's come before it from those same source systems. So we're doing things like applying AI to data sets that are coming in and comparing new data to historical instances of that data from a source system. And so we're looking for anomalies, doing anomaly detection, and trying to determine if the data has skewed in some way. And so we're applying, not only AI for the platform itself, internal to how data is processed within the environment, and we see other people doing things with a lakehouse style architecture, applying AI in the same way. But then we also give organizations tools to build their own models and be able to track the data and the quality of the data that they're using to train those models.
Thanks, Chris. I'll say I've been very impressed with what I've seen with the Databricks stack. So thanks again for being here.
Sure.
Would anyone else like to follow up on that? I know that one's really a softball for Chris, but Paul, Nancy, anything you want to add?
No, I think Chris covered it. Anomalies in the data
Right.
history.
Great. So this one's for everybody. What other risks do market research companies face related to artificial intelligence?
The list is really long.
The list is really long. I guess maybe do a top three.
So CMOs are really concerned about copyright and generating creative, which violates copyright, or generating text, which violates copyright. You mentioned generative AI is not very good at lit reviews. The fact is, it's trained to sound like a person, right? It's trained to communicate. Basically, it's trained to pass a Turing test, but it doesn't know what facts are. And so when you do a lit review, you'll get a reasonably comprehensive answer that probably makes a lot of sense, and the sources are entirely made up, or very often entirely made up. I know the agency community is concerned that AI is the new offshoring. I think Deloitte has projected that something in the order of 40,000 jobs will go away in the advertising industry. because of AI over about the next maybe 5 years. Bias in algorithms, we've known about that for a long time. People with light digital signatures aren't represented in the training sets. And perhaps, maybe most significantly, there's actually an HBR article published last summer, which really was quite positive about the use of AI, but expressed a real concern that everything is going to be a regression towards the mean. If we're all using the same large language model trained on the same internet, we're going to start getting a lot of average answers. Creative development, creative generation is going to regress towards the mean, and we're going to start seeing very similar creatives being generated.
That's great.
Yeah, I guess I would add to it just, we tend to think of kind of 4 stages of developing a model that you would present in front of a human being that would interact with it, and how you might evaluate their responses. You start with sort of the traditional foundational models, the ChatGPTs of the world, and you use them based on how they've been trained by the organizations responsible for them. You can then take sort of step 2 in terms of maturity, is you take those foundational models and you fine tune them with your own data, and you try to get them to be more accurate for answering questions that people might have. You can add in RAG, which is retrieval augmented generation, which is basically a lookup against a knowledge base. And then finally, you might want to take a foundational model or start from scratch and build your own model and train those models with your own data. But, you've got risks at each stage, and costs certainly at each stage. One example that came out just in December was a Chevy dealership was using a very commonly used Gen AI model to have it answer questions for consumers about their products. And unfortunately, and there's articles about this, unfortunately, it recommended the Ford F-150 as a great truck, on a Chevy website. So you've just got to be careful with understanding what data was used to train the model and how that model is going to be used, and what are some of the consequences of I wouldn't call that a hallucination. It's just, it's been trained to understand sales information on Ford F-150s and took that data and gave it as a recommendation on a Chevy website.
I have a question for Chris.
Sure.
What about siloed systems? So we have a huge archive at the ARF of 90 years worth of papers, presentations, and all. Do we protect ourselves by building a siloed system, or maybe we use a white labeled model, but we're only training it? We're not training it on the internet. We're not using a generalized version of ChatGPT. Does that solve the problem of the Ford F-150?
Yeah, potentially it can. I think what you're going to see is in the future a proliferation of smaller models trained on very specific domains. So, ChatGPT, for example, is an amazing capability, but it's very broad-based, and you can ask it, 1,000 different types of questions across a bunch of different domains. Organizations that have a good corpus of data that's really specific to their problem set and their domain, they could take a foundational model, one of the open source ones, and either fine tune or fully train from scratch. You can also use RAG as an approach. So, it really depends on the architecture and how the data is set up, and whether or not you want to be able to query that data set in real time as a question comes in. But if you've got a siloed data set and you feel the data set is of good quality and it represents your business, that's just a great source of information to train a model against.
That's good to hear, because that's exactly what we're doing.
Yeah.
Yeah, Nancy, anything you want to add?
Yeah, I was just going to say, in terms of Gen AI, right, when it comes to data quality, of course, we are concerned that fraudsters may be using Gen AI. We don't necessarily think that a random consumer is going to take the time to really put something into a Gen AI model and then copy and paste it into a survey, but that is something that we do detect. If they do use that, do that sort of thing using copy paste, we do detect that and we toss that out. We also look at the structures of the open end. There's a lot known about how ChatGPT, for example, answers questions, and we can detect all that. I think over time, though, these language models will get better and better and better. And so we have to think differently about how we look at open ends. And that's what we've started doing within Dynata. And I wanted to say, too, is that there's a lot of opportunity in this area, some low-hanging fruit around operational aspects. So that, the coding, for example, a lot of people are using these language models to code and put coding frames in place and that sort of stuff. So there is a lot of opportunity from an operational standpoint right now in market research with these kinds of things.
Great, thank you. I have a couple more questions, but we've got such great engagement in the Q&A. I think I'm going to move to the Q&A. The first couple of questions all relate to quality score, so I'm going to throw this one to Nancy. The questions are around how we prevent bots from taking our surveys, which isn't just quality score, obviously.
Yeah.
Whether Dynata automatically removes respondents based on quality score, and whether the quality score calculation is impacted in countries where extraction of metadata is restricted, such as China. So let me start with you on that. Yes,
so I'm going to try to remember those three things. The first one, actually, let me take the middle one, which is quality, does it automatically remove? Yes, so what it does is it makes an assessment on a respondent for 3 different thresholds. So you're a good respondent, you're kind of on the bubble, which is my term for it. And then there's reject, remove these folks. These folks are either fraudulent or they're completely unengaged. They're just too unengaged. It's not their day to be taking a survey. So for the reject, once it gives that score and it falls under that threshold, it will automatically remove the people and replace them in real time with another respondent. And then you can go look at your data if you want, and it's the on the bubble people you just need to concentrate on. You don't need to concentrate on all the people that are considered good. So it really takes a lot of that task down for you. In terms of fraud, what it's looking for, we're really looking for bots, which are real people running automated scripts in a survey, and click farms, which are real people sometimes just clicking through on their own. And so there are patterns that are known, and we're constantly looking for new patterns. And we will be, we can detect them through how you use a mouse. The way that a computer uses a quote unquote mouse, because it doesn't have any hands, is different from a human who has hands and the way that they use a mouse. It's things like that. It's network latency lags. Like, do you see a lag in something? You may see a lag, you don't know what it is, but it's indicative of someone using a proxy server, for example. So there's a lot of different things that we look at that you wouldn't be able to see necessarily, a human can't see, but these are all things that are indicative of fraud. We actually can train these models, the models learn, and so we can start to see new patterns as these models show us these patterns, things that we may not have thought about that would be correlated and be indicative of fraud. So there's a lot we do in that area to find those. And I'm sorry, I forgot what the third question was, Stephen.
I actually think you got them all.
Okay.
So thank you, Pedro, Brian, and Oliver for those questions. Question from Mike's. He says that he's also seen AI be very bad at math. The example I love to use when I do trainings on this is you ask the AI question, I have 3 dogs, one's missing a leg. How many total dog legs do I have? Gives you the wrong answer. If you ask it to tell you how it would answer a question like that, gets the right answer. But let's throw this question to Chris. And his question is, what AI platforms are good at math, if any? I know that's an area Databricks is innovating in.
Yeah, I mean, I think this is an area where applying the right tool for the job is important. You know, a lot of people look at AI as, you know, it can solve any and every problem. It's, you know, software programming has been historically amazing at mathematics, right? If you look at, you know, the precision associated with applications that are built to handle trading, stock trades on Wall Street, and calculations, scientific calculations, the precision levels are fantastic. Yeah, if you ask what's 5 plus 5, and sometimes some models will give you 55 as the answer instead of 10. So I think it's really, as I said earlier, you're going to see more fit for purpose models being created that are smaller in nature and have been trained on data that's really, really relevant. And it was brought up about like software programming, and, you know, there's some questions in the Q&A around, will AI replace human beings? I think software developers, like, you can think about solving the programming skills, like the semantics, the syntax and semantics of programming. You could apply it not only to just a general purpose program, but you could apply it internally to an organization based on all the other software that's been written for that organization. So meaning I might want to have AI develop software on my behalf that looks and, you know, behaves similarly to other software built within my company. And so you could feed all of the GitHub repo for all the software that was built inside of your organization. The model will learn that. And when you ask it to write a SQL query or write a Python function, it will generate code with comments and things like that that are similar in nature to code that's been written before. But yeah, just straight up mathematics. I'm not an expert in that field in terms of what's being done in AI, but the programming languages themselves support it really well.
Yeah, one of the things I remember at the last Databricks conference, it kept coming up, was English is the next programming language, or whatever language you happen to speak. So yeah, that's great. Bunch more questions in here about quality score. Jay, speaking of disengaged survey takers, Jason mentions that he was distracted when Nancy mentioned how quality score can be applied in self-programming. Can you restate that briefly for us?
Yes, thank you for demonstrating what I was saying. We are in the process of piloting to see how we can deliver to our sample-only customers. So these are people who buy our sample and then would be able to get quality score along with that. But quality score has to be put on a hosting platform. So we're looking to see, okay, what are the common platforms that we might want to cover, and what does it take if a company has technical resources on their end versus not having technical resources, for example, because the company will need to, whoever buys it will need to, or gets it will need to put that on their programming. So that is, there will be more to come from us. Hopefully sooner. It'll be within the first half of the year, I think. So stay tuned if you're a sample-only customer or would like to be.
Thank you. This question around what is the Advertising Research Foundation doing in the space of artificial intelligence? I'm going to kick that to Paul in a second, but I should mention that I chair the trustee work stream on artificial intelligence for the ARF. We just released guidance for organizations on how to de-risk the use of generative AI in your organizations without stifling innovation. That's actually going to be available for you from this webinar. But Paul, you've done an expansive amount of work on this. Do you want to say a little bit about that?
Sure, happy to. So about 2 weeks ago, we published the ARF's guide to using AI in very specifically advertising research. The use of AI in marketing is a really crowded field. We're advertising research, so we focused on that. We did a comparison of Chat 4.0 Bard, because Gemini wasn't out when we started this, and Claude, because it's very popular among our MSI members who are academics. Claude 2.0, for which you pay $20 a month, same as Chat, was not out when we started this. And the handbook compares it on sort of all aspects of doing advertising research, except for creative. Creative AI is being used in creative in many companies right now. Companies that have 30 years worth of ad testing, they'll train in their siloed environment a system, and for $4,000 or $5,000 you can get a creative test, as opposed to what used to be much more expensive. We use it to start every survey. The first thing you do, best practice, is to ask for an outline, and then you kind of curate that outline section at a time. You also indicate either who the audience is, who the sample is, if you're writing a report or if you're conducting a survey, and from what perspective. The handbook talks about developing a survey in media research. So in the very first set of prompts, write the survey questions out from the perspective of a professional media researcher. It is good at translation, especially we use it for translation, or at least the first stage, especially for either German or Romance kind of languages. Less effective for Hindi, less effective for Mandarin, sort of in the middle for Hebrew. We obviously have a very international research department at the ARF. It is, you mentioned lit review, for reasons that we've already discussed. It is not good for something like a lit review, because it's really not trained, on facts, or what is a fact. So I think you mentioned it. It really is sort of being used every day by the research folks at the ARF. And then the larger utility will be the development of this siloed system, which is trained on our 90 years worth of papers and presentations. Very specifically, it would cover just about anything you'd want to train a model on with respect to advertising research.
Thank you so much, Paul. And just one quick plug for those of you who are not ARF members. All of this is available to ARF members. It's a great time to become a member of the Advertising Research Foundation.
Thank you for the plug.
Thank you. One more question I'm going to pull out of here. There are probably a few dozen that we haven't gotten to. We will get back to those and send those out. There was a question about synthetic data and how to manage data quality when we're talking about synthetic data. So just a quick note, that's where you're asking the language model to give you an answer rather than going out doing primary research or asking people. I have a lot of thoughts about this, but let me open this up to the panel. Chris, do you want to lead with this? Or would you rather I kick it to somebody else?
No, happy to. I spent 5 years at Capital One, where we were building algorithms to detect financial crimes, fraud, money laundering, those types of things. Background in the intelligence community with counterterrorism and entity correlation for human beings that had partial data about who those people were and where they might be. And then, of course, now at Databricks, helping with the platform architecture. Synthetic data is a really challenging problem, and this really gets into data sovereignty and different legislation that exists globally around how AI can be used. There was a question in the chat session about biometrics and facial recognition. The EU has put out legislation, just approved a few months back, where facial recognition cannot be used for consumer type applications for large-scale events and things like that. It can be used for law enforcement, but then not in real time. So there's a bunch of legislation that I think is going to have to be tested in courts in order to really sort of bear out exactly how it can be interpreted. But synthetic data is important because, when you're trying to develop systems at scale and you've got real data that has GDPR or CCPA implications because it has PII info inside of it, finding some way to abstract that data out, anonymize it, but make it realistic, but not really pertain to a specific human being. There are companies that are just popped up over the last few years. I don't have any names to give you for those companies, but that do a decent job of taking your real data and finding ways to anonymize it. We had to go through an exercise at Capital One following a data breach in 2019 to go through and tokenize customer information and ensure that none of that data was in the clear, especially as it's persisted in the cloud. So it's a big initiative that I see a lot of companies starting to get involved in.
Thanks. We're running a little over time. I'll just say, I'll just add my own 2 cents as the moderator's privilege, and then we can close out. As it relates to surveys, what the research has been suggesting, where you ask Gen AI instead of asking survey respondents, is that it's not doing a great job. There's a lot of regression to the mean, like Paul was describing earlier, which is to say there's not a lot of variation in the answer. It tends to give you the average answer. It doesn't understand questions with emotional context or affect particularly well. And of course, these language models tend to be a year or 2 years old. And so the data underlying those large language models tends to be fairly old. So at this point, it's very difficult to think about using it in place of humans for that kind of research. Let me thank you all. There's a ton of questions. I really appreciate the engagement. We will get back to you. The recording will be available for those of you who want to watch it again or share it with friends. And as I mentioned, we'll follow up with you guys by email. So thank you so much. Appreciate your time and your engagement, and look to see you at a future webinar.
Yeah. Thanks, Steve.
Thank you to the panelists. You guys were fantastic.
Thank you.